today I'd like to present my working paper, and basically it's about voter coalitions in decentralized finance. And so this is the outline of my presentation today. And I like to start from motivation. So in corporate finance, we say, okay, governance is quite centralized. We see, for example, in a corporation, we usually have a CEO, and we usually have several managers, and we know usually decisions are decided by these people. And if you are just a normal employee in a corporation, usually you will not participate in crucial decisions. But in DeFi and DAO, people say, okay, now things will be different because we will introduce decentralized autonomous organization, in short DAO. And in DAO, actually, there is no centralized legal entity, and we do not see employment contracts. And actually, the aim of DAO is decentralized organizational governance and decision making. And actually, we hope that DAO will be led by community instead of centralized authority. So then we have a question. So we do not have managers or CEOs. How do people make decisions? So usually decisions are jointly made by all members or DAO members, and the results for governance will be recorded on blockchain. So it is to say everyone, theoretically everyone, even though you are not a member of some DAO, you can still find their governance results because these results are recorded on blockchain. And this picture introduces how these DAO people make decisions. So for example, this guy has an idea, and the other DAO members may want to know what this guy wants to discuss. So this guy needs to write a proposal to carefully introduce his idea and probably offer several options. And then DAO members can choose an option that they like. And usually this progress will rely on voting. And when the voting process ends, we know there will be only one final decision, and the results will be documented on blockchain. And then we have a question here. So how do we decide the voting power of different people? So a popular solution is that many DAO issue their own governance token, and they will have their own rule. For example, one governance token equals to one vote. And in this way, we say, okay, DAO and the underlying DeFi protocols are actually governed by holders of governance token. So then people may say, okay, it seems that DAO is very different from corporate finance. And then we want to, the supporters will say, okay, DAO will be the future. And our motivation is that we want to know if it is true and if there are any new problems in DAO governance. So in this paper, we want to answer this research question. So do voter coalitions exist in DAO? So actually, if you are a finance person, this question is not very new because we know voters or shareholders are not separated individuals. And in corporate finance, there are many papers discussing shareholder coalitions. So for example, shareholders with similar goals and interests can form coalitions. And so we hope that we will see similar things in DAO governance. And let's use this picture as an example. So we know everything, also every decision relies on voting if we want to participate in DAO governance. So then if we assume that there is a voter coalition, then the voters in this coalition may tend to choose the same options in a series of governance polls. And on the other hand, if we see there is a group of voters and these guys always choose share the similar voting patterns, then we can say, okay, actually, they are a coalition. So in this paper, we try to detect voter coalition in DAO. And here I like to present a preview of findings. So in this paper, I use MakerDAO as a case study, and we find 5 potential voter correlations. And among the 5 correlations, we found, okay, there is a largest one, and the correlation has the most voters and the most total votes. And we also consider the group cohesion of the voter correlations. So we introduced an index widely used by people in political science, and the name is Agreement Index. And then we found that both voting share and the group cohesion of these correlations can influence Maker protocol. So for example, DAI is more volatile when the largest correlation has higher voting share. And finally, we study how voter correlations can influence DAI flows to different on-chain applications. For example, we want to know when one largest voter correlation is more dominant, we want to know if the DAI flows to lending protocols and the decentralized exchanges will be affected. And then I'd like to show our data and methodology. So we have mentioned that I use Maker protocol as a case study. And actually, we have already witnessed some fight between the co-founders of MakerDAO. We see there is a proposal named the Endgame. So basically, the story is that the 2 co-founders of MakerDAO have very different opinions on the future of Maker protocol. So what they did is like they proposed endgame, and other voters can participate in governance, and they will need to choose the options that they like. So then we conjecture that MakerDAO governance may be just a competition of several voter coalitions, because we know, okay, again, the DAO voters with the similar preferences will form a coalition and maybe choose the same option. And our data sets are about governance polls in MakerDAO. So basically, these polls are about non-technical changes. For example, if you want to change the interest rate, you need to propose a governance pool. And we choose governance tools from pool 16 to pool 838. And actually, there are more than 800 successful governance pools in our data sets, and everyone can get the the records from MCD voting tracker. And after collecting the data set, we find 17 unique addresses of voters. And if you want to get voters' public names and their labels, you can use Maker Governance Portal and Voters Pro. And then a key problem of this paper is that we need to find a way to cluster the voting patterns of different voters. So here we just follow what machine learning people do, and we use Kimi's algorithm. So the basic idea is that voters with similar voting patterns will be clustered as a voter correlation. So here we see we have VIJ. Actually, it denotes the option of voter I in poll J. And we know in governance polls, usually the options are written in text. So what we need to do is we replace textual options with values. So for example, if a governance pool has 3 options, yes, no, and abstain, we will assign 1, -1, and 0 to these 3 options respectively. So for example, we can see if VIG equals to 1, it means voter I choose yes in poll J. And in our data sets, we assign 0 to abstain. And if voter I doesn't participate in poll J, we also let VIJ equal to 0, because actually his choice is abstain. And then we have a question is that we need to decide how many voter correlations we should we should have. And we also follow what machine learning people usually do. So we use elbow method and the COHA score, and this we have two graph, we have two figures here, and these two methods suggest that the optimal number of voter correlation should be 5.
Can I ask a question? So I guess the first question is, how do you have an idea, like, for example, for these unique voters, how often do they vote? Do most of them always vote, or like there's like 40% of the voters vote 80% of the time, or something like that? Do we have like a general idea of how often these voters vote?
So actually, I may say, even though we see more about say 2,000 voters, but they will not, not many voters will participate in many polls. Actually, only a small group of voters will frequently participate in governance polls. So if you see the raw data sets, we may say, okay, if you have more voting power, you will tend to vote more frequently. But if I only have say 0.01 votes, probably I will only participate in 1 or 2 polls.
Would that then, okay, then maybe kind of related to my second question is, so when you do k-means, usually you run into these like curves of dimension, the curves of dimension issues that I imagine the larger the total number of pools you have, the less likely you will find anything, in the same, like near the same space as one voter's behavior. Is there any adjustments for that?
Yeah, so before applying k-means, you need to first do a principal PCA,
right?
Yeah.
So I guess that because there's a lot of people that doesn't vote, so they will all be, for a lot of votes, they will all be abstain in your data set. Have you tried like remove this 0 and then see how similar voters are?
Yeah, I'm thinking about it and probably do it and add this part to robustness checks. But for this version of the working paper, I haven't done it, but I think it definitely is what I should do.
Got it. Thank you.
Thank you. And if we, after clustering the voters, so it's quite easy to compute their voting power. And so here I will just skip that one, and I will like to introduce how to calculate a group cohesion. So here we use the measurement named agreement index, so in short AI. And so here we can see this equation, and let's use an example here. So assuming that this pool has 3 options, so yes, no, and abstain, and we will have yi, ni, and ai. So actually, they know the votes of yes, no, and abstain from coalition I, respectively. And then we can calculate agreement index for coalition I in this pool. So here, this term is actually the maximum of yi, ni, and ai. And here, this term yi plus ni plus ai is actually the total votes from coalition I in this governance pool. And similarly, if there are more options, let's say more than 3 options in a governance pool, we can calculate AI in the similar way. So here we see from option 1 to option J, and we know option J denotes the votes of option J from coalition I. And it's easy to see that AII will be a number between 0 and 1. So if the members, also the voters in coalition I, all choose the same option, AII will be 1 for that governance pool. And if the voters in coalition I distribute their voting power evenly among different options, then we say, okay, AII will be 0. So it means, okay, the people are not cohesive. So a higher AII means that a better group cohesion of coalition I. In other words, the voters in coalition I will tend to choose the same option. And then I'd like to start introducing the empirical results. So first we have some statistics about voter coalitions in MakerDAO. So we say, okay, there are 5 different coalitions and there is a largest one. So we say voter coalition 0. And we can see it has more than 1,600 voters. And I will say, okay, most voters in this coalition is quite, how to say, minority voters. They may just participate in 1 or 2 governance polls. And we can also see coalition 0 has the most total votes in our data sets. And actually, the how to say, the first poll that the coalition 0 participated in is in 2017, actually quite earlier. And if we focus on the coalition 1 to coalition 4, we will say, okay, the number of voters are not very, how to say, they only have several voters, but actually their total votes are not that small. So still, this smaller coalition can be influential. And this pie chart gives us a better understanding of the dominant coalition 0. We can see their total votes are actually more than half of the total votes in MakerDAO. And then in this figure, we can see the voting share of cluster 0, coalition 0 in different governance polls. So we can see, for example, in this polls, okay, coalition 0 is really dominant because we can see their voting share is quite close to 1. But in this polls, maybe from governance pool 200 to pool 300, maybe their voting share is quite close to 0. It is to say they do not, how to say, vote in this polls. And if this is the case, the smaller coalitions can win this polls. And then an important question is, who are the voters? So what we do is that we collect some labels to show the financial activities of voters in MakerDAO. So here, for example, we have ENS owners, Twitter users, DEX traders, and liquidity providers, and so on. So we can see more than a half of voters in coalition 0 are actually trading cryptocurrencies on decentralized exchanges. And we can also see more than 1/3 of voters are NFT traders. It is to say these guys have ever bought or sold an NFT on Ethereum blockchain. And we know in MakerDAO, there are MakerDAO delegates. It is to say they are quite like representatives in MakerDAO governance. And we can see, okay, most of the delegates are clustered in coalition 0. But if we want to focus on MakerDAO delegates, we can see, okay, there are 4 delegates in coalition 2. So maybe coalition 2 is also quite influential. And then we try to collect their public names. And we found, okay, there are many interesting people in coalition 0. So for example, we see some DAOs with the name of famous universities. For example, we see Chicago DAO. Actually, this DAO is based on University of Chicago. And we also have blockchain at Columbia. Actually, this DAO, this address is about Columbia University. And we also see London Business School, but we do not know why these names will show in MakerDAO governance. And in coalition 0, we also see some venture capitals, which is quite influential in crypto. For example, we see an address that belongs to A16Z. And we also see some crypto OGs. For example, we can see Fossil is a voter in coalition 0. And because we see there are 4 MakerDAO delegates in voter coalition 2, so we try to know who are they. And we see, okay, we see these 2 guys in voter coalition 2. Actually, these 2 people are quite influential if you are in MakerDAO community. So sometimes they may write some Twitters, they also write some posts in MakerDAO website, and some followers may just follow their suggestions. And then I like to show the agreement index of voter coalitions. And if we focus on the average AI, we will say, okay, smaller coalitions are more cohesive than the largest one. So we can see their average, their mean is usually more than 0.9, while the mean here for voter coalition 0 is only 0.84. And then we use this figure to illustrate the agreement index of coalition 0. We can see, okay, in this post, AI for coalition 0 is quite low. So in this case, other coalitions are more likely to win, especially when they concentrate on a certain option. So basically, we have a feeling that MakerDAO governance might be just the battlefield of different coalitions. So sometimes the largest coalition win, while in some other polls, the winners will be the smaller coalitions. And then what we do is that we want to know how voter coalitions influence Maker protocol. So we have already calculated the voting share and the agreement index for the 5 coalitions. And then we are interested in 3 specific factors of Maker protocol. So we know DAI stablecoin is issued by Maker protocol, and since it is a stablecoin, we are interested in DAI volatility. And we also want to know how total revenue of Maker protocol is affected. And in DeFi, network adoption is really important. So we are interested in daily new users who borrow from Maker protocol. And what we do is that we estimate some regressions. So here on the left side, we see factor. Actually, we have 3 different factors. And in our regression models, we will put voting share or agreement index on the right. And we also have some control variables because we want to exclude the influences of these variables. And then we can see the relationship between DAI volatilities and the voting share of voter coalitions. So for example, the meaning of this number is that DAI will be more volatile when coalition 0 has more voting share. And these 2 numbers show that, well, the voting share of coalition 2 and coalition 3 is higher, the DAI will be more stable. So basically we see, okay, the existence of the largest voter coalitions might be bad because most people want to say the stability of DAI stablecoin, while the smaller coalitions seem to be, a good thing for Maker protocol since it contributes to DAI stability. And then similarly, we see some results for total revenues of Maker protocol. So here we can see this number shows that, okay, when the voting share of the largest coalition is higher, the revenue of Maker protocol will decrease. But here we see these 2 smaller coalitions can increase the revenue of Maker protocol. But here the complicated thing is that this small coalition can also decrease the total revenue. So actually we can see, okay, the influence of the voter coalitions can be very complex. And then after studying the influence of voting share, we focus on group cohesion. And here we see the coefficient related to coalition 0. The meaning is that when coalition 0 tends to choose the same option, also when the coalition 0 is more cohesive, we can see, okay, DAI will be more stable. And here we see this, this finding means that when the, coalition 4, which is a smaller coalition, tend to choose the same option in governance polls, we will see, okay, DAI will be more volatile. So that's quite a little bit word I'd like to say. And here I'd like to give some potential explanation. So when the largest coalition is more cohesive, it is to say this one is more likely to win. And since we know, okay, most voting power is controlled by coalition zero, for normal people or say other investors, we will say, okay, the voting results are quite predictable, and we will know that what will happen in the future. And we can have our, how to say, trading strategies, and we can do something before the final decision is deployed to the blockchain. So as a result, DAI might be more stable. And for this finding, we will say, okay, usually we will not see a smaller coalition can win a governance pool. So when it happens, we can say, okay, the results are not that predictable. So probably everyone do not know it will happen. So we do not execute certain strategies, and as a result, DAI can be more volatile. But anyway, we can do more in the further research to investigate the finding here. And when talking about the total revenue, okay, in this table, the largest coalition doesn't show any influences on revenue or Maker protocol, but we can see, okay, the smaller coalitions show quite complicated effects on revenues. So for this one, this coalition might be good, might be a good thing when the voters tend to choose the same option, because we see, okay, the revenue is higher. Well, when the voters in these two coalitions try to distribute their voting power, okay, the revenue of MakerDAO will decrease. So actually things are quite complicated. And the final subsection is actually about DAI flows to different on-chain applications. So we know if we issue some DAI, and we can trade DAI on centralized exchanges, DeFi, or we can trade it on decentralized exchanges or say lending protocol, and we can also just hold them in our own addresses. And if we want to transfer DAI to different blockchains, the first step is that we need to send DAI to bridges. So in our regression models, we first collect variables called DAI transferred. So actually it measures the amount of DAI transferred to the 5 different categories of on-chain applications. And on the right side, we will have voting share. And also we have some control variables. And then we can see how the voting power of different coalitions will drive DAI flows to different places. And in this table, we can see we summarize our results. So we see some plus, and we also have minus in our table. So for example, this plus means that the higher voting share of coalition 1 can increase DAI flows to CeFi. And here we see a minus, and the meaning is that when the voting share of coalition 4 is higher, the DAI flow transfer to CeFi will decrease. And then let's focus on CeFi first. So if we focus on, we are interested in DAI flows sent to CeFi, we will say, okay, in this way, coalition 1 and coalition 2 might be allies, because we know when these two coalitions have more voting power, okay, both of them choose to send more DAI to CeFi. Well, coalition 4 seems to be an enemy of these two coalitions, because we see, okay, when coalition 4 is more dominant, probably they do not like CeFi. And similarly, we can think about their interest in DEX lending protocol, because we can see, okay, probably the results here are related to their private benefits.
Sorry, I have a clarifying question. So when we say here on the left hand side, your voting share, that's just their how can we like interpret it? Should we interpret it as those let's say, past proposal, which are supported by these voting share for, or are we are just thinking about these? Do we control whether or not the proposal passed on the
So
current
actually,
issue?
sorry. So actually, the voting share matters. How to say? Actually, we use the votes casted in governance polls, whether they choose yes or no. So, even though in a coalition, voters can choose different options because, they have different interests sometimes. So for this measurement voting share, we will just put all votes from a coalition together. And that's why we introduce agreement index. So that measurement can introduce more, how to say, there are these similar opinions within a governance pool. So that's why we have two measurements.
I guess my question is more on are we controlling whether or not the proposal eventually passed, and that will make an impact? Because even though we think about the agreement index for, let's say, voting share 0, it's very large. They all vote yes on a certain issue. But if that issue is not passed eventually, proposal, then we shouldn't expect too much impact on the DAI flow, right? Or should we still expect it has an impact on DAI flow because these information are public and then people could make inference from the decisions.
So I think this question is quite, how to say, an open question, because actually we do not know these DAI users, how they utilize DAI stable coins. So actually we do not know if, how to say, assuming that there is a governance pool that are not passed, we do not know if they will, how to say, transform more or less DAI, or say they just give up using DAI. So probably some, how to say, probably we can do some further research on it, but in this paper, I do not discuss much about it. But I think it's quite interesting because, for example, you can use some more complicated regression models, try to exclude the influences of the governance pools itself, I think. I think it's a good question indeed. Well, shall I continue?
Yes, please. Thank you. Yes.
Well, so in this way, we will see coalitions can be both allies and enemies of each other. And my guess is that how coalitions drive DAI may be related to their private preference benefits, just like what Kite said. Like, for example, if I see a governance pool is passed, I may say, okay, I will use more DAI. That might be a reason that we see increasing DAI flows. And if I say, okay, I wish this governance pool can be approved, but finally it was declined, maybe I just give up using DAI stable coins, and it may lead to how to say, less DAI flows. That's quite possible, and we believe that some further research can how to say, show us more evidence. And okay, finally, I'd like to introduce some contribution. So first, this paper show how to identify voter coalitions in DeFi and DAO, and the clustering algorithms can help us to review potential voter coalitions. And in corporate finance, actually, shareholder coalitions are a very important research topic, and we expand research to DeFi and DAO. And actually, in traditional finance, we say, okay, large shareholders can form coalitions for extracting private benefits, while minority shareholders can form coalitions for protecting their own interests. And in DAO, we believe that, okay, similar things are happening, and some further research can try to find more evidence. And we believe that the analysis about DAI flows partly review the financial activities preferences of MakerDAO voters, even though our analysis is not perfect. And we hope to see more papers about it. And finally, we provide some insights into influences of voters and the shareholder coalitions, because we see, okay, the existence of coalitions are not always a good thing. And finally, I'd like to conclude my presentation. So again, we find 5 water correlations in MakerDAO, and we say, okay, water correlations have very complicated influences. And even though we see, okay, there is a largest correlations, but it can be bad at some times, and it can be good for some certain questions or problems. And in this paper, I like to say, okay, we have some limitations. So for example, we run some regression models on the daily basis, but actually we do not know the long-term effects of existence of water correlations. And we also want to know more about the reasons why the waters form correlations. We believe that if we can, get more information about their financial activities on blockchain, probably we can, describe their preferences, also their goals of trading DAI and other cryptocurrencies. But for now, I may say, okay, this is one of the main limitations in this paper. And here I believe that it comes to the end of my presentation, and any questions will be welcome. Thank you.